So we've gone over how to use elimination on something that has two variables, so like x and a y. You want to get one of those variables to match, so you can add them with opposite signs so that they eliminate each other. So we're going to take it a step further. Today we're actually going to do the same process, but this time with two variables, we're going to add a third one in. So instead of it just having x, y, they're also going to throw in a z. So it'd be x, y, and z that we're solving for. When it comes to solving these, just right off the bat, these take a lot longer than the other ones do because you have to solve for three variables instead of just two variables. So you have to do a little bit more work with the equations when it comes to rewriting them. And you actually do kind of like a double elimination. You try to get rid of one of the three at first, so that then you're just working with something like you saw yesterday where you had the two variables, so that then you can go backwards again and plug back in once you have something that you know to help you find the other ones. The reason why we solve with three variables is because it is possible to graph three-dimensionally. You know, we live in a world that's not two-dimensional, it's not flat. Okay, so we have things that are always measured in 3D and all of those kind of different measurements. So graphing can happen in the three-dimensional world too. We don't do a whole lot of that in this class, but it is out there, and that's kind of where these equations come from. So we have what's called ordered triples, okay, and that's just when you have 3 points instead of 2. So typically you guys always see x comma y. They're just adding in another letter. Does it have to be x and y and z? No, it could be any 3 letters that are being used to represent a point out there in space. But it follows kind of the same situation as before, that when you solve it, when you get the coordinate, if you plug it into all the equations, they should all balance. So that's kind of what you're looking for. Now there's three kind of main solution types that you can find when you're trying to solve using elimination. One of them is one solution, and that's when three individual planes intersect at one point. Think about like the corners of a room, like the corners of my room here. There's 3 planes that are intersecting there. There's like the front wall, so this red wall, the wall over there that the clock is on, and the ceiling. When they all intersect at that corner, that one point would have 3 pieces to it, an x, a y, and a z, because there's 3 planes. There's the front wall, the side wall, and the ceiling. So that's what's happening when there's one solution, when they all meet at one point. They kind of have that central location crossing. Infinitely many solutions would be the line that if like those 3 planes kind of all share this one line. Think about like the doors that revolve. It's like if you're going into like a big building, sometimes they have those doors that are constantly going in a circular motion. You guys know what I'm talking about? So those doors, they're kind of set so that the center is the line that kind of connects all of those dividers that divide it into those different slots that you can jump into. And so as it rotates around that center point, that's where all the solutions would be. So that would be an example of infinitely many, because if those doors kept growing, that center line would keep growing too. Then, of course, there is the no solution. This is when there's no common points, so either they never intersect, or even if they do, not all 3 intersect at one spot. So they give you a couple different situations for all of those there, picture-wise, for you guys to kind of think about when this would happen. So we're going to do some examples of actually solving these now. So if you guys get to the next page, this is when we see the first one. Okay, so like I said earlier, I'm not going to sugarcoat it for you. These are going to be a little bit longer of a process than the ones that you did yesterday, because you have just more work that you have to do. So the stuff that you're doing, though, is similar to what you did yesterday. You're still going to maybe have to multiply an equation by a number to get it match another equation. And then you're still going to be adding equations together to try to get things to eliminate. So we've got 3 equations here. Normally what I do to kind of help keep them separated instead of me like just referring back to the equations is I number them. Equation 1, 2, and 3. So I do that so that later on when I start pulling equations, I can just use the numbers. So when I talk about equation 2 or equation 1, you know exactly which one I'm referring to. So I don't have to read out the whole equation to you again. So at this point, you kind of have to look at your letters, your X's, your Y's, and your Z's, and you have to just make a decision about which one do you want to try to get rid of entirely from all three equations so that you're down to a system that only has two. It doesn't really matter which one you pick. If there's one that appears that it would be easier, then maybe do that one. But if there's one that doesn't look like it's going to be any easier than another one, then you can just decide. Whichever one you don't like, you can get rid of. So what I'm going to do is pair up equations 2 and 3. So I'm going to rewrite equation 2, which says 2x plus y minus z equals 5, and x plus 4y plus 2z equals 16. So I'm going to get rid of my x's. What I'm going to do to the second equation, because the second one just has an x, is I'm going to multiply all of this by a negative 2. So now I didn't do anything to the top equation, so I'm going to leave that as 2x plus y minus z equals 5. So I'm just bringing that whole equation over. Now on the bottom, make sure that you take that negative 2 times every single term. Think about your distributive property. Think like you're taking negative 2 and you're drawing those arrows into all the terms on the inside there. So you got to make sure you do it to every single one, not just the x term. So you have negative 2x. Negative 2 times 4y is going to be negative 8y. So minus 8y. Negative 2 times that 2z is going to be negative 4z, so minus 4z. And then 16 times negative 2 is negative 32. So I got my x's to have the same number. They both have 2's. One of them is positive, one of them is negative. So just like you did on the previous ones with just two variables, I'm going to add these equations together. This is going to cause those x's to cancel, eliminate, and I just add the other pieces together. So I have y plus a negative 8y. So that's like 1 plus negative 8, which would be negative 7y. Negative 1z plus negative 4z would be negative 5z. And then 5 plus that negative 32 is going to be negative 27. Okay, while we haven't done any solving quite yet, we have done some significant work here because we've gotten rid of the x's. We do have a new equation. And so what I need to do is pair up another set of these x values, another set of those equations 1, 2, and 3, to get rid of the x's again so that I can take the new second equation and pair it up with this one. So that then I can try to get rid of either y or z. And that's why I said you're kind of doing a double elimination on these problems. You have to eliminate one of the variables first to get to a system of equations like you saw yesterday. Now don't pair up 2 and 3 again. You don't want to pair up the same equations that you just did, or you're going to get the same answer, and then when you try to combine them, everything ends up canceling out and you're stuck. You've got nowhere to go. So instead, pick a different pairing. So you could put, instead of 2 and 3, you could put 1 and 2 together, or you could put 1 and 3 together. Again, it doesn't matter which ones, but look at those x's and figure out which ones you think would be easiest to try to pair up so that you could just maybe multiply one equation by a number to get it to eliminate. So I'm going to take equation number 1 and equation number 3. So I'm going to write them down like you see them. So the reason why I picked 1 and 3 is, again, I'm trying to get rid of my x's. I see 5x and then I see just regular x like we saw up above. So for this one, I'm going to take the entire bottom equation times a negative 5. That way those x's become opposite terms, so that when I add them, they'll eliminate. So again, I don't do anything to that top equation, so I'm just going to drop that over to the right here. 5x plus 3y plus 2z equals 2. For the bottom equation, take everything times negative 5. So it says negative 5x, negative 20y, negative 10z equals 16 times the negative 5 is going to be negative 80. And then I'm going to add again. My x's cancel, which is what I want to see happen. You want to get those same variables that you canceled before to do it again. So 3y plus negative 20y is going to be negative 17y. 2z plus a negative 10z is negative 8z. And then 2 plus negative 80 is going to be negative 78. So we've done this so that we can get two new equations that only have two variables. This is going back to what we did yesterday. When you're solving something with two variables, you just have to try to get rid of one of them. So I'm going to take these two new equations here and stack them like we did before so that we can work with those two to try to eliminate some stuff here. So I'm going to bring down that negative 7y minus 5z equals negative 27, negative 17y minus 8z equals negative 78. So we have to eliminate y or z, doesn't matter which one. You're going to have big numbers no matter which one you do, because you're going to have to multiply both equations by something. So if you're trying to get rid of the z's, let's say, right now you have a negative 5z and a negative 8z. What's a number that both 5 and 8 can go into? Close. 40. So what I'm going to have to do is take the top times an 8 and the bottom times a 5. However, since they're already both negative right now, make one of them become positive by multiplying by a negative. That way they'll eliminate easier when I add them. So it doesn't matter which one you do. I'm going to take the top one times positive 8. I'm going to take the bottom one times negative 5. So this is what you guys were doing yesterday. So the top times 8, again, you have to do it to every single one. You're going to just be working with some larger numbers here, but don't let that scare you. So negative 7y times 8 is negative 56y. And then we have negative 40z equals negative 27 times 8 is negative 216. Now for the bottom, we're taking them all times a negative 5. Everything is going to switch signs here because they're all negative. So it's going to become positive 85y, positive 40z, and then positive 390. Once again, we're going to add. Your z's are going to cancel. Negative 56 plus 85 is going to be positive 29y equals negative 216 plus 390 is 174. To solve for your y, you divide both sides by that 29. And y is going to come out to be 6. Now that you have y, we start our process of plugging it back in, working backwards to find those other variables. Do not go back to one of your original equations just yet, because the original equations had 3 variables. We only have one of them solved right now. So what you want to do is go back to one of the equations that you were using earlier, so these ones that I have in green. Pick whichever one and plug in y. I would maybe do the top one just because negative 7 smaller than negative 17 when you're doing that math. So I'm going to take negative 7 times 6 minus 5z equals negative 27. So I have negative 42 minus 5z equals negative 27. Add 42 over. So you have negative 5z equals 15 when I add 42 to negative 27. What's going to be 15 divided by negative 5? Negative 3. So z is negative 3. So far we have found y and we have found z. Now we can go back to one of the very original equations. So if we scroll back up here for a minute, we can come back up to one of these three, plug in the two variables that you know to find that third one. Again, it doesn't matter which one you go back into. I'm just going to use the very bottom one. So it says x plus 4y, so that would be 4 times 6, plus 2z, so 2 times negative 3, equals 16. So I have x plus 24 minus 6 equals 16. So I'm going to take 16, I'm going to add 6 to it, I'm going to subtract 24. Or you could combine 24 and 6 and then subtract that over. I'm going to end up getting x equals negative 2. Proper technical answer form is to write these as an order triple. So x, comma, y, comma, z. Put those in parentheses, so it would be negative 2, 6, negative 3. If you happen to forget to put it in that form, it's not a huge deal, as long as I can find your 3 letters somewhere in your work. So as long as I can physically see where your x, where your y, where your z is, if you forget to put it in the order pair, it's not a huge deal. Just know that that's how they would probably want you to write the answer, though, is as that order pair. All right, so these take time to get used to. Do not try to rush through problems like this because it is super easy to make a mistake, especially if you're not watching your signs carefully. Watch those negative signs when you're adding, subtracting, and that. All it takes is for one negative sign to get missed, and it messes up the entire problem. So take your time when you're working through these, and it's not uncommon for it to just not work out or for you to get a mistake, and it's okay if you mess up. Just go back and try to find what you did wrong. Retrace your steps backwards if you need to. All right, let's take a look at this next one. Okay, so we start again. I'm going to number them 1, 2, and 3. You got to make a decision first about which letter you want to try to get rid of right away. So I would look at the X's, the Y's, and the Z's. What I notice when I'm looking at these is the X's, the top and the bottom ones are positive, the middle one's negative. So it might work nicely if we put like 1 and 2 together and 2 and 3 because you already have opposite signs. You would just have to multiply one of the equations by a number. So I might work with the equations to get rid of x first. And again, because they already have some opposite signs happening, but also that middle one is just an x. So that's really easy to manipulate by just multiplying to like a number instead of having to multiply multiple equations. So I'm going to try to get rid of my x's, and I'm going to, like I said, pair up 1 and 2 together, and then I'm going to do 2 and 3 together as well. So let's start by just writing these out. Okay, so for the first two, for 1 and 2, what number do we want to take the second equation times to get it to eliminate with the top x? 4. What do we want to do for the second pairing? What do we want to take that top equation times? For the second pairing, good, 6. Okay, yep, and we leave, for the first pairing, we leave number 1 alone. For the second pairing, we leave number 3 alone. The only one that we're really kind of working with here is number 2, and we're doing it twice because it's easy to get it to just have the same number, opposite sign from the other equation. Okay, so let's rewrite these now. Again, don't do anything to that first equation, so it's still going to say 4x minus 3y plus 6z equals 18. If you rewrite the second equation, it should now say negative 4x plus 20y plus 16z equals 192. So we're going to add. X's are going to eliminate. What's negative 3 plus 20? So we have 17y. What's 6 plus 16? So plus 22z. And then 18 plus 192 is going to be 210. Okay, for the bottom one now, we have negative 6x plus 30y plus 24z equals 288. And that bottom equation stays the same. And then we add. So we're going to have 28y plus 29z equals 288. In my opinion, that is honestly the worst part of this whole thing, is you have to try to get rid of one of the letters at first. You have to just make a decision about which one you wanted to get rid of, and you got to do a little bit of work. Now, this next step is like what you did yesterday again. As I said earlier, there's chances that you're going to have some pretty ugly numbers that you're working with here. Like, they're just going to be big, okay? But don't let the fact that you might have huge numbers, and I'm talking like sometimes they get to be in the thousands, don't let that make you think that you're doing something wrong or intimidate you, okay? They're just numbers. So you can work with large numbers just like you can with small ones. Now, for these ones, because we've already got like 17, 22, 210, 28, 29, 288, these are going to be some pretty big numbers that we're working with here. Okay, so be prepared for that. I'm going to go ahead and stack them. Okay, and this, like I said, this is not a nice setup because really there's not great numbers for these to go into. I think what I ended up doing for this one is I just tried to get rid of the y's, and I just have to multiply the top one by 28 and the bottom one by 17, and I think I even took the bottom one times a negative 17 to get it to switch signs. So I'm taking the top times positive 28, the bottom times negative 17 to get them to flip signs. And like I said, this is why you're going to have some pretty big numbers here. So the top equation is now going to say 476y plus 616z equals 5,880. The bottom equation says negative 476y minus 493z equals negative 4,896. And again, I'm just multiplying 28 into everything, negative 17 into everything. So right now they look pretty massive, these numbers, but they do really simplify down nicely. So my y's cancel. Those are gone. So I take 616 plus a negative 493, or 616 minus 493. I get 123z, and then 5,880 minus that 4,896, I get 984. When I divide by 123, I get 8. So z equals 8. So we're back down to a smaller number. All right, so if you remember, I said from here, you take 8. Don't go back up to one of those original equations quite yet. Go back to one of the new ones that you rewrote. Okay, so come back into one of those there. Okay, it doesn't matter which one. I think I just picked the top one because it does have a little bit smaller numbers. Not great, but they're smaller than the second one. So we have 17y plus 22 times 8 equals 210. 17y plus 176 equals 210 when I simplify that. Then I subtract 176 from 210 and I get 34. So 34 divided by 17 is 2. So y is a 2. Okay, and then go back up to equation 1, 2, or 3. Pick whichever one you like the best. I think I just went back into number 1 to solve for my x. So it says 4x minus 3y, so minus 3 times 2 now, plus 6z, so 6 times 8 equals 18. So we now have 4x minus 6 plus 48 equals 18. Move those numbers over to the other side, so you have x all alone, so it says 4x equals negative 24. Divide by 4x comes out to be negative 6. So again, as an ordered pair, we would write that negative 6, 2, 8. There are a couple more in your guys' packet, and these are special cases. So these are kind of really rare ones that you don't see a whole lot of, but I do just kind of want to show them to you guys so that you know what to do if you encounter one like this. Most of the time, the ones that you have on like an assignment are going to be able to be solved, but we did talk about, when I went over kind of the 3 main types of solutions, these 2 that we just saw would be when there's one solution. So that would be like when my 2 walls in my ceiling met and they form that corner point. That's that coordinate for that one singular point. Now there's other situations when there's infinite solutions, meaning there's an unlimited number of solutions out there. And then there's the other option where there's no solution. So there's no answer to it. So I want to show you guys one of each. So for this third one, if I were to try to solve it, we would start exactly like we've done before. We start by numbering all of these equations. I'm going to put equations 1 and 2 together, and 2 and 3 together. So I'm just going to write these down. So I'm gonna, just like before, try to get rid of my x's here. So on the first one, the first pairing, equation number 2, I'm gonna take times a -2. So I don't do anything to the top one. So I'm just pushing that all over. Now the bottom one is now gonna say -2x minus 4y plus 8z equals -14. And then I add my equations. X's cancel. I've got -3y plus 5z equals -9. For the second grouping, I'm going to take the second, or the first equation, so equation number 2, times a -6. Again, trying to get rid of my x's. So the top equation is going to change now. It's going to say -6x minus 12y plus 24z equals -42. I leave the bottom one alone. Add them. X's cancel. And I've got -9y plus 15z equals -27. If I look at my two new equations here, and I go and I stack them, my y's are probably going to be the easy ones to eliminate because 3 can go into 9. So I'm going to take that top equation times a -3 because that'll cause it to switch signs, but I want you guys to see what's going to happen when I do this. So when I take -3 times that top equation, -3 times -3 is +9. So now it says 9y. -3 times that 5 is going to be -15z. And then equals -9 times -3 is +27. The bottom equation stays the same. I'm just writing that down. What is going to happen when I add these equations together? Do you guys notice anything about the equations? So that we've got 27 and -27, so that's a 0. What's going to happen on the left side? More zeros, because if you guys look, it's the same numbers. It's a 9, a 15, and a 27. They just have opposite signs. So the y's cancel and the z's cancel. I end up with a 0 equals 0 here. I can't do anything beyond this. I've basically just eliminated everything from my equation. So when this happens, this tells you that there's infinite solutions. Okay, there's nothing that I can do beyond this point. If I went back and I regrouped and I repaired the equations together, so instead of doing 1 and 2 and 2 and 3, if I tried to do 1 and 3 and 2 and 3, let's say, it's still going to do the same thing. Eventually, I'm going to get to two equations that look exactly the same. They just have opposite signs. And again, I've got infinite solutions happening. So this would be that case, like I talked about the revolving doors, that they all meet in one center place. They share a line forever, and so there's an unlimited amount of solutions out there. The other case is a no solution situation. So on the last page here, again, I'm going to start by labeling these 1, 2, 3. I'm looking at my y's for this one. If I put 1 and 2 together, so 3x minus y minus 2z equals 4. And 6x minus 2y minus 4z equals 11. If I take the top equation times a -2, trying to get my y's to cancel here. When I take negative 2 times that top equation, it says negative 6x plus 2y plus 4z equals negative 8. And the bottom equation stays the same. So, look at these numbers again. Just like that last problem, do you see how you have like 6x, 2y, 4z, but they have opposite signs? The top one's negative, the bottom one's positive. The top one's positive, the bottom one's negative. They just kind of have the same numbers, but they all have opposite signs. So everything on the left side is going to cancel. The x's cancel, the y's cancel, the z's cancel, and you're left with a big 0. But the right side doesn't cancel. What's negative 8 plus 11? 3. Is 0 the same thing as 3? No. Okay, so this is not a true sentence. That means that there's no solution for this one. The last one was infinitely many because 0 equals 0. Okay, 0 and 0 are the same thing, but 0 and 3 are not. So that's why this one's no solution. And again, if I tried to go back and I picked equation 2 and 3 instead, and I tried to eliminate one of those letters, the same thing is going to happen. Everything's going to cancel on the left side, but I'm going to be left with a number that's not the same as 0 on the right side, and I'm stuck.